Good afternoon, good late afternoon. Actually, it's about 7 p.m. right now. It's actually evening time. And this door should look familiar to you. First of all, it's kind of stuffy in here, so I am going to put the air conditioner on. Finally, that miserable, horrible heat and humidity finally broke. It's still not as dry as it should be, but the dew point's supposed to be in the 40s, and the lows are going to be in the 50s tonight, like tomorrow morning, Saturday morning, and that's great. But right now, we've got the air conditioner shut off in the house, except for the my son's and the front room. The bedroom one, I only run at night until the humidity gets down. Tonight, I probably won't need it. But we're going to have to put it on here, and we're running, believe it or not, our voltages are back up to 118 and 119 now, but that doesn't always stay there. But it's stuffy in here, so I want to run this for a little bit on medium cool. So, as you can see on the bench here, from the capacitor test here, so I'm going to clean all this off, and then I want to work on something here that I should have done a while ago, and I've been watching YouTube videos on it, and I will tell you what that's going to be very shortly here. Okay, I've been looking at some YouTube videos on how to make a high voltage probe for a digital meter, such as these types that are, most of them are 10 megohm impedance. Not all of them. Some of your cheaper ones are a lot lower than that. And I have here a 100 meg resistor that I got off of eBay. I was going to use this in my high voltage power supply, which had an analog meter, and the full scale was 10. So putting this in series with the meter, I'm able to read 10,000 volts. But we're going to go one step further, and I'm no good at math, but we're going to experiment by putting a 10 megohm resistor here. Now, your meter leads will be connected at this point, your negative here and your positive here, with a 10 megohm resistor here. Alright, let's move that out of the way here so you can see it a little better. The negative continues right on to the alligator clip, which will be connected to the minus side chassis or whatever of the equipment, and also runs straight through to the meter, to the negative on the meter. Here we have a 100 megohm resistor. So now I don't have any 9 meg resistors. Normally you'd put 9 meg resistors in here, and I think you'd put a 1 meg here. I'm not positive. We're going to experiment. I can't do formulas, as I told you so many times. So how we're going to test this, according to the videos I've been watching, is this meter is auto-ranging. This Fluke 73 is auto-ranging. So you'd put it on DC volts, and what you want to do is to try out a lower voltage. Like, let's say you want to measure 6,000 volts, okay? So if you put a 6-volt battery across here, you'll read a fraction 0.6, 0.06, whatever it is on here. And because this is auto ranging, this may or may not work on an auto ranging, I don't know. But because actually what you're doing is you're measuring the voltage drop across this resistor right here. And this is your dropping resistor so that you can safely feed in 6,000 volts or whatever. Well, we're not measuring that high, but I'm using that as an example. What we are going to be doing is measuring the voltage of these electric Flyswatters. Okay? This one was a freebie that I got the other day at Harbor Freight. I haven't bought anything in Harbor Freight in a long time, so I was going to get off the mailing list if I didn't act quick. So now I'm getting all kinds of coupons in the mail. This is the second Harbor Freight electric Flyswatter that I've gotten. The first one I scrapped and tried to modify the voltage in here by adding another diode and a capacitor to make a voltage doubler. What I had done is taken my VTVM, which will read 1500 volts. I set it on 1500 volts. Not on this one, but on the first one I had. And I read about 500 volts DC. So these Harbor Freights only put out about 500 to 600 volts DC. And the capacitor that's on it is 630 volts DC. Matter of fact, this is the power supply that I removed and took the capacitor out. They had a Mylar cap. There was no capacity listed on it, but it was 630 volts DC. So these things don't even, the Harbor Freights don't even put out 1,000 volts. It don't even put it. So I took out everything except I left the diode in. So this is a high voltage diode. And I had added another one. I took out all the capacitors and everything on this. And I tried to modify it, and even when I modified it, I just barely got about 1,000 volts out of it. I took out the 630 volt, and I put in a 2,000 volt capacitor that I pulled out of that old tectonic scope that I junked. So I had two of those capacitors in there. They were like the 001s, I believe they were. Disc, high voltage disc. And I still couldn't get much out of it. I can take this one that I got from, I got a bug up here, dead bug. I got this at Ocean State Job Lot for $3.99. It's a little smaller than this. I can take and touch this on a blade of grass and it'll zap. I can do the same with this. They both got fresh batteries in and nothing. So I'm figuring this has only got about maybe 500 or 600 volts at best on this. The only difference with the one I had first was it took 2 D cells. This one takes 2 AA's. So the Harbor Freight ones don't zap. I've taken these out today, both of them at the same time, and I was zapping mosquitoes all over the place. Snap, 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 everything. Nothing on this. But it is putting out voltage. Very little. I can take a screwdriver down there, there's a little spark. I do the same to this one and it really zaps up something. So this is about 3,000 volts. It doesn't say so, but it's about 3,000 volts output. So I want to measure the voltage on these things. So that's why I want to make a voltage probe, but I'm only going to do it on clip leads so that I can get an idea of what the voltage is on these. So we're going to set up the camera on a tripod so that you can see me do it. I'm just going to set these things up on clip leads. We're only dealing with about 500 or 600 volts here and 3,000 here. So for an experimentation, we're not too bad off. We can do clip leads and experiment with it. So let's get you set up here on a tripod. All right, I don't have a 6 volt and I don't have a 10 volt except let's say I use my power supply. So we're using 9 volt, and right now we're going directly. We got this 10 meg ohm resistor across here, but that's not going to be really mattering too much. And we're reading 9.84 because this is a brand new battery. Now we'll move this lead to the 100 meg ohm resistor, and we'll see what we get here on the meter. Well, we've only got 0.506, so that's really not telling us too much, is it? I do everything by experimentation. So what we've got to do is, what did I say, 9.6 something? So we've got to get 9.6 volts. Not 9.6, 0.96 volts, I believe. Like I say, I can't figure these things out. All right, let's go back over here again. I don't even know if I'm not on macro, so it's probably going to be out of focus, but I need you to see the meter. All right, we're going back over directly to the battery now. I got a mind like a sieve when it comes to numbers. 9.84, 9.85, okay? So we probably should get 0.985. 9.85, we got to remember that. Let's go back over here. No, so that's really not telling us anything, and from what I've been understanding, and then they don't really explain it too much, and when they do, they use math formulas, and then I click off the video because I won't watch that. I got a 10 meg ohm resistor across the 2 leads here, okay? So one of the videos, he had a potentiometer across here to adjust it, which makes a lot of sense. But I don't think you can get a 10 meg ohm potentiometer. I don't think they make that. I could be wrong. So this is a 100 meg ohm resistor here. See, I have a problem. Let me show you what I've got for a high voltage probe that I got from eBay a year or so ago. Hang on. I used to have 2 of these. I had a 30,000 volt and a 42,000 volts when I was doing televisions. I didn't do that many, but I did do a few. This is a Pomona. The only problem with this, get you down on the macro here, is it's very, very difficult to read 2,000 or 3,000 volts because you're way down at the bottom of the scale. It would be nice if this was 10,000 volts full scale or switchable. So, in a sense, I really need a 10,000 volt full scale or even a 5,000 volt full scale high voltage probe. It's a 600 meg 2%. Okay, and the resistor's in good shape. I had to repair, some wires were broken in the back of the meter also. But I got it as a good price. I think it was around 25 bucks or so. Okay, I'm going to connect up the 9 volt battery now. It's unreliable. You can't use an auto ranging digital meter on this. What I did is I put another 10 meg ohm resistor in series right down here. and I had to hold this with one finger. Not across it, but just on one. So, we can't use an auto ranging meter on this. That's one thing they did not say on the YouTube video, but it's probably goes without saying. So I think the only way I'm going to be able to do this, I'm going to try this with my other meter. So hang on a minute, because this way we can confirm once and for all that whether this is going to work on a digital meter at all. The proof would be in the pudding, because if it don't work here on the bench, it's just not going to work in real life. But let's turn this off, because this is auto ranging. I'm going to get the Radio Shack meter out, and that is not auto ranging, and I can set that on whatever voltage range I want, and then maybe it'll become stable and I'll be able to juggle this resistor around. I added a second 10 megohm resistor across here. It didn't make all that much difference. I'm not getting the right readings on here. I'm not getting the right readings at all. And like I say, I do everything by experimentation. I just can't figure this out. And you know, I've looked at a lot of videos and they're very vague. They don't really explain things very well. And that's why when I do something, and if I know something, you know, and I try to pass it along with you, I explain it like I would like somebody to explain things to me. Because that's the way I can learn, and I feel that if I can learn that way, and sometimes you may say, well, it's a little dumb to repeat yourself and to go over and over something. But in my case, that is the way I absorb things, and I can learn. Learn by repetition, you know, doing it over and over again. So that's why I'm a tinkerer. I experiment with these things. I don't do formulas. I can't do them. And it's just too difficult. I just can't. So I do everything by experiment. I have no idea what the resistor is. I thought because they're supposed to be 10 megohm resistors in series here, which makes 100 megohms already made up, that maybe you use a 10 mega here. Now, if the right way I think I'm supposed to do it is 10 9 megohm resistors here, which would be 90 megohms, and one 9 megohm resistor here, which would make the 10th one. But I don't have those resistors. I do not have that many. I might have like 8.2 meg and something like that. So, and to buy a high voltage probe made for these meters are outrageously high priced. So, if this don't work out, when I put the other meter on, I have an analog meter, which I know this will work on because I experimented before. I think the meter is 100 mils full scale. Don't quote me on it. It's put away. It's that high voltage power supply that I never did finish. And that's why I bought this resistor. Alright, enough chattering. Let me get on to the non-auto ranging meter and see if I get any better results. Okay, I'm getting a stable reading. So obviously you cannot use an auto ranging meter with this setup, but it's not a good range here. It's not working right. Here's the direct. You can't even see the lead here. Alright. Okay, let's go. Alright, on the 20 volt scale, 9.9 volts. Okay? 9.9 volts on the Radio Shack, direct on the battery. We still got the 10 megohm resistor going across here. So now we'll move. Now remember, now this is 9.9. So I should be reading 0.99 if I'm not mistaken. But I'm not. I'm reading 0.4. You see it? 0.48. So, what does that mean? I got to increase this? Well, I've already increased it using the other meter by putting another 10 meg ohm resistor in series with that. So, I know this ain't going to work. So, we're going to eliminate this confusing thing here, this voltage divider. Right here. We're not going to use the voltage divider. We're going to eliminate that, and we're just going to read this in series with the hot lead, and we'll not use this resistor here. Let's just see if we get a proper reading then. Look at that. It's a little off. It should be 0.99, okay? So, you do not put a resistor across, even though that YouTube video, and I'm not going to give a link to it because, you know, I disagree with that. When you want to drop voltage, all you need is a high voltage resistor in series. So, okay, so we're close enough. Now this is 0.9. Let me see. I don't think my meter will go down any lower than that. Yeah, 200 millivolts. I think that'd be too low. Over limit. Okay. All right. So we're 0.9. Go to the 20 volt range. We're 0.9. Okay. We are close enough, folks, that I'll be able to measure the voltage on that electric Flyswatter. All right. Let me show you what I got here now. These little clip leads, these came off of that little Chinese crap meter that I had that everybody raves about. Those little things without the case. I saved it when I threw the rest of it out. So I've got this hot lead on the center grid, which is on these things that you're probably well aware that the two outer grids, in this case, is on the negative, and the center grid is the high tension, because obviously you'd get zapped if these two outer grids were a different potential. Okay, so I got the green one on the outer grid, and that's the negative. Of course, it could be reversed, it could be positive. It doesn't matter. The point is there's a potential difference there. Let's get this off. So these plastic sleeves, they should be, for what little voltage this is putting out, it's not going to matter. So let's push the button on this thing. We're over limit. So let's go to 20 volt scale. We're still over limit. What's going on here? Let me shut it off and put it back on again. Why is that doing that? Okay. Maybe it was putting out too much voltage. Alright, let's go. Let's push that again. Alright, it's negative. The center grid is negative, but that don't matter because when the Chinese put these things together, they just throw them together. 122.6. I would say, 1200 volts? I don't think so. $122. Well, I'm on the highest range now, 122. I'm gonna watch out I don't knock my meter over here. Oh, that has a good spark. But it won't do that outside with the zap. It don't zap anything. So maybe it's about 1200 volts. Okay, we're on the green one. Let's push the button on the green one. $157. All right. A lot more energy. Now, this one here, you got a tall blade of grass, it goes up in here, it zaps just like a bug. Nothing on this one. Nothing. No zapping of mosquitoes, flies, or anything else. It doesn't do anything. Yet, there is voltage there. So, this probably is a candidate for a voltage doubling circuit in the future. But I really hesitate to make anything like that on video, because there's always some nut out there that will hurt themselves, and I will not be responsible for anything stupid that anybody does. You do all these things at your own risk. This is only just a scientific video, just to kind of like show you about making a high voltage probe for a digital meter. And nothing more. Don't worry, my VTVM's off. All right, so in actuality, you do not need a resistor going across here, because it doesn't seem to work out too well. Now, maybe if you have a real high resistance here and you get the right ratio of resistors, maybe. So I can't say one way or the other. All I know is this works for me. I have an analog meter, as I said, and I can measure up to 10,000 volts using a 100 megohm resistor in series with the analog meter. Now, that Pomona that I showed you, that's an analog meter, and I don't think there is a shunt resistor across the meter like I showed you with the 10 megohm over here at the leads. I think it's just a simple high resistance meter in series with the high voltage. And the rest of the circuit is completed through the meter movement. And for safety reasons, so you don't blow out your meter, because you see how fluky this got, and it kept flashing. It could have gotten overloaded, maybe, possibly, because of such high impedance. So, if you're going to experiment, and this is only my opinion, and opinions are like bungholes, everybody's got one, you're safer to use an analog meter. You just got to figure out what resistance you're going to use, and in my case I do everything by experimentation. And if I had more time and enough resistors to work with, I could probably come up with something. But I only need to measure the voltages, and I wanted to measure the voltages of these to verify what they are. So this one puts out about half of what this one does. It's dark out there now, so I can't show you with a blade of grass. But this one will snap every time with You hit a blade of grass with it, the blade of grass goes up through the grid, zap, 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 just like a fly. Nothing on this one. Nothing on the other Harbor Freight that I took apart. So, this will need to be modified. Any modification of this thing here is a future thing that I may or may not do at all. Like I say, I may not do this at all. It's just something to think about. That's all it is, just on the planning stages. But anyways, this video is about the high voltage probe, which is not going to get made right now. But in the future, I may build one using the analog meter that will read 10,000 volts full scale. Thanks for watching. We finally got some weather we can breathe again. Starting tomorrow. Tomorrow's Saturday. I'm going to Big Belly Kelly and I'm getting another great breakfast. I don't know about any yard sales. That just hasn't been any around. I think there's one a few miles away I want to check out, but I'm very, very limited on cash, so I'm not going to be doing too much. Alright, thanks for watching. It's great to be in the shop again. I hope you enjoyed your little visit with the blind tinkerer in his workshop. Thanks for watching. Take care, everyone. And don't do anything I wouldn't do. And if you do, do not name it after me.